And I've got a QR code for my slides up there if anyone wants to see them as well. So after a brief introduction of contextual AI, I've got two demos for you. The first one is dynamic MCP selection. So I think a lot of folks are going to talk about building MCP servers, but with so many out there, there's a new challenge of selecting the right one for your project. Then, once I've selected the right MCP server for my project, I'm going to show a little bit of multi-agent context engineering via remote MCP servers. I'll talk a little bit about how that second demo works behind the scenes, share a few lessons from setting up our remote MCP server, and then wrap up. So Contextual AI was founded by the pioneers of RAG, Dawa, Keela, and Aman. And Dawa was the last author on the RAG paper that came out of Meta 5+ years ago. We really focus a lot on research, and we're a Series A startup. And so what we focus on is kind of building this unified context layer that lives between your experience layer, which may be your agent or your workflow or API, and between your data, typically unstructured. And that context layer includes query execution, agentic search, data management. And so we kind of started as a RAG company, but what we're finding is that context engineering is essential for more advanced agentic use cases. When LLMs came out, you could get a lot of leverage out of just prompting. RAG evolved to incorporate enterprise or private documents, and then things are kind of evolving into agentic search and autonomous agents. And so for my first demo, I'm going to use our re-ranker to look at Pulse MCP's database of servers. So there's over 5,000 servers there. So how do you select the right one for your task? We're going to compare our re-ranker and a baseline approach, which would just be maybe doing something like in context. And I can also describe my attempt to manually find the right server for this task. So our re-ranker is the first instruction following re-ranker. So on the left here is kind of how you would just call that re-ranker within the context of RAG or as a standalone component, as I'm going to demo today. And then on the right, you can kind of see that as you change your re-ranker instructions, your retrieval results will change. And so we're able to really specify the instructions based on not just the semantic matching, but also specifying the metadata. And so I'm going to show this dynamic MCP selection in a notebook that we've created for this. And we also have a blog on this topic that's also linked in that notebook. And so you start with the user query. There's first an analysis step to see if you need an MCP server or not. And if you do, it'll generate, an LLM will generate that instruction for the re-ranker. Then Contextual AI's re-ranker will score these servers and then give you a ranked list of which one is best for your task. And so here's my notebook. I'm going to go through it pretty quickly just to kind of share the highlights, but it's available for you to check out as well. So first we start by setting up our secrets in Google. So we're using our contextual API key, and you're welcome to try this with a free trial as well. It's a $25 free trial or $50 if you use your work email address. And then we're also putting in here our OpenAI API key for that model that decides if you need an MCP server and creates that prompt, and also as our baseline approach. So after initializing these clients, we've created a data set for our re-ranker from all of the MCP servers from Pulse MCP. And so we are pulling all of that information. We're getting the names, descriptions, metadata like GitHub stars, whether there's remote server. And then we're creating documents and metadata based on that information. So those documents are going to be the server name and description. And so then what we're going to do is just have an example query, like find most recent information about CRISPR gene editing applications in treating sickle cell disease. I need trustworthy sources. And so we have our prompt for the LLM that will generate the re-ranker's prompt. And then we're deciding, that model is deciding, yes, we do need to use MCP, and then writing those re-ranking instructions that will kind of expand on that user query. And then here, now we're using Contextual AI's re-ranker to re-rank those documents. And so here you'll see the results like the score, and the highest scoring MCP server is a biomedical database. So these are, from our own kind of manual review of these, this kind of lines up to what we would be looking for in that scenario. So as I was coming up with my second demo for later, I was thinking, you know what? I want to send an email or a text or call someone via MCP. I want the server to be remote and have higher user rating. I was looking for something to communicate externally. And funny enough, even though I had this notebook, I just did a quick manual search. I was like, this must be really straightforward. I'll just do a search. I couldn't find anything. I thought maybe Twilio voice app, but they don't have a remote server. So I try my re-ranker here, and it says, yes, you do need an MCP server for this. Rewrites the re-ranking instructions. Select MCP servers that offer capabilities for sending emails, texts, and making calls. Ensure the servers are remote and have high user ratings. Prioritize those with user-friendly interfaces and reliable performance and communication services, which was a better written instruction than the initial prompt I had. And so the top-ranked MCP server was Active Pieces. I had never heard of it. I tried it out, and I set it up in just a few minutes, and I'll kind of show you the demo, the full demo with that MCP server and Contextual's MCP server later. And so if you compare to an in-context query that has some of that same information, but isn't able to process the metadata because there's not like a separate field for that in context, you would get actually like a list of servers that are not remote at all. So the baseline approach was not very effective. We did find that for easy queries, like help me manage GitHub repositories with automated testing and CI/CD workflows, you're looking for a GitHub MCP server. Those you don't really need like a re-ranker for, but we found that for queries with specific requirements, for more complicated queries, you would see much better results. My personal favorite is this last one here. I have many complex enterprise documents. I want to build an agent that lets me interact with and query these docs through natural conversation. Our re-ranker recommended our MCP server for that task, which we are not paying it to do, but objectively it is, I would say, a very good fit for that task. And cost-wise, our approach kind of costs just cents, like 3.5 cents to get, to save a lot of time in manually selecting that optimal MCP server. And so now that I've selected the right MCP server for my task, my next demo is going to show you multi-agent collaboration via remote MCP servers. So what I have here is a multi-agent email sending based on RAG outputs that was all set up in just minutes. I'm using the Contextual AI remote MCP server for our end-to-end RAG platform, along with the Active Pieces remote MCP server that I found in my re-ranking search. And so these MCP clients, these remote MCP clients can connect via an MCP server to our API, and that lets you query a RAG agent that you would have set up in Contextual AI's platform in a remote MCP setup. We've got some more resources along this in the slides if folks want to try it on their own, as well as in our documentation and our GitHub repo. And the RAG agent I created for this was a RAG movie agent. So I gave the agent a 241-page table from Rotten Tomatoes. It's a pretty simple table. It's got movie titles, release dates, critic and audience scores, but it is a very large and long table. And so for this demo, I'm using OpenAI's platform as my coordinator here. Hopefully you can see this here. Maybe I'll zoom in a little bit. So the way I set this up, if you're not familiar with OpenAI's platform, is I've set up a couple of tools here. So I have my Active Pieces email agent that I set up in just a few minutes, and my Contextual AI MCP server that I also set up very quickly. I have a little system prompt here telling it which agent to use. That's my movie agent, and this email address will be relevant to the next part of my demo. So let's say I want to find out, I want to name some movies with 100% critic score, but not 100% audience score. Kind of maybe a critic's darling film that was not as appreciated by a more broad audience. And so this MCP client has now called the contextual AI assistant here with this query, and then generated the responses. I'll show you in a little bit what that looks like in the contextual AI platform, but I've looked at these before. These are very accurate. These are not made up movies and scores. These are very accurately read from the table. And then let's say for my next prompt, here, I'll put my mic down so I can type. Send the first movie to my husband to say, we're watching it this weekend, add a haiku about MCP, and send the whole list. Oh, no, that was my typing. That was my one time to type. I can read it now. Okay, so what I typed in was, send the first movie to my husband to say, we're watching it this weekend, add a haiku about MCP, and send the whole list. So these are 3 different agents here now, or 3 different tools or agents. So we're getting that information that we pulled through the contextual AI RAG agent. OpenAI is writing this haiku, and then my email agent is sending this email. And here's my inbox where I tried this before, and it'll say, thank you. Hi, we're going to watch The Butcher this weekend. The MCP haiku is MCP whispers truth, circuits hum in gentle night, answers in the code. I think that part could use some improvement. And then that full list that I asked it to send. So what I really like about this is that we're kind of getting out of that chat window and we're able to share information more broadly that we may have retrieved in our RAG system. And just as a quick peek at what's underlying the contextual AI MCP server, so here's the agent I had set up, also in minutes. We offer the fastest way to get an accurate RAG agent. I do workshops and webinars to kind of walk people through setting this up, but it's very quick. Here's kind of the response that we saw before within our client. And you'll see these little numbers here are actually like citations that show you where the information was found in the table. And then underlying this agent is a data store where I had loaded this movie info, and I can kind of load it and look at the rendered table and kind of inspect the data if I wanted to do that. So great. Just to give folks a sense of how this is all working under the hood, the contextual agent is taking information from your data sources, unstructured data, ingesting it through a data understanding pipeline to a data store, and then we have our RAG agent that combines a mixture of retrievers, the re-ranker that I demonstrated earlier as well, and then from our grounded language model, we're getting output that can go directly into our GUI in an API via MCP, and offers state-of-the-art performance out of the box, top benchmarks for end-to-end accuracy for benchmarks like RAG QA Arena, as well as separate components. Kind of removes the need to do all of these time-consuming tasks on the right here to focus on your business-critical AI use case. I'll just share a few highlights about the system. There's a lot of different approaches against hallucinations, from state-of-the-art retrieval, a specifically fine-tuned grounded language model, and then groundedness checks and the attribution bounding boxes I showed earlier. Our extraction and parsing pipeline really does a lot of interesting things, like getting the layout analysis, the full document hierarchy, image captioning, and adding that metadata. And then in our retrieval step, we've done the query reformulation and set up the hybrid search and added filtering and re-ranking steps. And then lastly, I wanted to share a few insights from building that remote MCP server that I demonstrated earlier. So there actually aren't that many on Pulse MCP. I was surprised. And I think, part of it is that there are some challenges when you're moving from local to remote. For example, different clients would require distinct configuration. So you kind of have to plan which clients you're going to configure for. For example, for OpenAI, we needed a stateless HTTP model, so we had to add that flag. So for each client, we had to test out the server and make sure that it works. And then, security is always a big concern for MCP. And so the way that we've approached it to not allow this MCP server access to kind of get more access than it should is that we're kind of treating it like an untrusted pass-through model. So that MCP server is treated like an untrusted hosted client. You'll use your user credentials, but then it's acting as just a pass-through to existing API. So this limits the scope and prevents privilege escalation. It's a pretty simple model, but it avoids complex vulnerabilities and does its function as well as it needs to. So in conclusion, one, don't select MCP servers manually or in context. Use a re-ranker. You'll save a lot of time. And check out our remote MCP server for robust context engineering capabilities in minutes. You can get started by creating a free account, reading our documentation or example notebooks, or reaching out to info@contextual.ai. And if you're just interested about learning more, we have a lot of content coming out on MCP servers. We just put out a blog about the re-ranking approach today on our blog site, and we're sharing more information there about our work with MCP and some exciting updates about our re-ranker coming soon. I'm also the founding mod for the context engineering subreddit, so feel free to join there as well to take the discussion to Reddit. Thank you.